small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So for this problem, in my opinion, I think it's a bit easier to find the probability that this is not the case. So 1 minus the probability that every row is unavailable for the couple. By unavailable, I mean that either the middle seat is going to be taken, which makes that row unavailable automatically, or if the left and right seats in the row are taken, then that row is unavailable. Of course, if all 3 seats are taken, then it's also unavailable. So first we point out that the number of ways that the 8 passengers can seat themselves is 12 times 11 times 10 times all the way down to 5. However, in order to save a bit of computation, we can actually look at the number of combinations of 8 seats chosen from 12, since they'll be equally likely. So there are 12 choose 8 ways to choose 8 of the 12 seats on this airplane. And since we know that 12 choose 8 is equal to 12 choose 4, and 12 choose 4 is equal to 12 times 11 times 10 times 9 over 4 factorial. This turns out to equal 495. So we can find the number of ways that the first 8 passengers can seat themselves, divide that by 495, and then subtract from 1 to get our answer. So to do this, we'll do casework on the number of middle seats that are taken. The reason for this is because if one middle seat is taken, that automatically makes the entire row unavailable. So our first case, we'll call it case 0. Case 0 is that no middle seats are taken. So what happens in this case? If no middle seats are taken, then in order for every row to be unavailable, the 8 passengers must all sit on the left or right of the airplane. And this can only happen in one way. Our next case is going to be case 1, where one middle seat is taken. Now we need to be a bit more careful here because there are 4 choices as to which middle seat is taken. Let's say that the top row, the middle seat in the top row is taken. Then for every row to be unavailable, we need that the remaining 3 rows, the left and right seats are occupied because the middle seats in those rows cannot be occupied. Next, now we've seated 7 of the 8 passengers. Now we need to figure out where the 8th passenger can sit. That passenger can either sit in the left or right seat in the top row. And there are 2 possible ways to seat this remaining passenger. Now remember, this only considers the case where the top row middle seat is taken, so we need to multiply our result by 4. So overall, we get 4 times 2, 8 ways to choose 8 seats on this airplane such that exactly one middle seat is taken and the couple cannot sit next to each other. Next, for case 2, if 2 middle seats are taken, let's say that the first 2 rows, the middle seats are taken. This is going to imply that the remaining 2 rows, the left and right seats in that row, are taken. So now we've seated 6 passengers, and the remaining 2 passengers must sit among these 4 seats in the first 2 rows. So the number of ways to do that is 4 choose 2. But remember, we also need to multiply by 4 choose 2 because there are 4 choose 2 ways we can choose 2 out of the 4 middle seats to be occupied. And 4 choose 2 is 6, so the number of ways is 36. For case 3, where there are 3 middle seats, again, we're going to be doing the same thing, just with different numbers of middle seats occupied. With 3 middle seats, you see that the remaining row, the left and right seats must be taken, and the remaining 3 passengers must sit among the 6 unoccupied seats in the first 3 rows. So the number of ways that can happen is 6 choose 3, and then we have to multiply by 4 because there are 4 ways to choose which 3 middle seats are taken. Now 6 choose 3 is equal to 20, so 20 times 4 gives us 80. Lastly, if all 4 middle seats are taken, then the remaining 4 passengers can sit anywhere among these 8 remaining seats. No matter where they sit, every row will still be unavailable. So the number of ways for this case will be 8 choose 4, and 8 choose 4 is equal to 8 times 7 times 6 times 5 over 4 factorial equals 70. So we've exhausted out every possible case. The total number of ways where the 8 passengers can sit, it can be found by adding up these numbers which we've boxed. Now remember, this is just counting the number of combinations of 8 seats because every combination is equally likely. So the probability that every row is unavailable is going to equal 1 plus 8 plus 36 plus 80 plus 70 all over 12 choose 4, which we established was 495. This is equal to 195 over 495. And this fraction can be simplified to 13 over 33. Now remember, we want 1 minus this probability. So we're going to subtract this from 1 to get our answer. We get 20 over 33. And if we look at the answer choices, we do see that 20 over 33 is among the choices and is our answer. So the answer is C.